Welcome everyone, and thank you for attending this webinar. I'm going to talk today about data handling in Stella. I'm Bob Eberlein, co-president at IC Systems. So I'm going to move fairly quickly, but before we get started, just a couple of notes on the webinar mechanics. There's a little grab tab on your control panel that should allow you to control things. The audio, hopefully you can hear us. If you can't, you can send a note through the chat, which is where you can submit questions about content, but some of the early questions obviously are going to be about mechanics. Hopefully someone can get back to you through the chat to answer those questions. So in this overview, I'm going to spend a little time setting context, not much, and then I'm really going to go through a whole bunch of different examples of ways to import, export, and work with data in Stella. So I'm going to do a basic import example, constants, graphicals, and time-varying data being brought in, a basic export example to CSV and Excel files, talk a little bit about opening data as a model, which is a good way of exploring data and setting up imports, then using models to process data, aggregation and transposition of data, and then formatting input and output data in Excel, just a way to work with data easily. I'm going to touch very briefly on data interfaces, so I won't actually do an example of that, and then we'll follow that with a Q&A time, hoping to talk for about 40 minutes and have 20 minutes for questions. So in setting the context, one of the things I like to think about is where do we get data from and what does it really mean? And this is a kind of a view Jay Forrester developed of the world where there's a mental database that has an incredible amount of information in it, a written database that has less information, but is still quite rich, and a numeric database that consolidates things to numbers, which in a sense is quite small, although certainly the number of bytes that are consumed by that nowadays is huge. The content of it is relatively limited. We only measure a relatively small number of things day-to-day life relative to what we actually experience. And so in building models, we want the richness of that mental database to help us with the conceptualization and framing of the model. And we use that numeric database for parameterization of values, dynamic drivers, and calibration. But we should recognize that it is a subset of the information available. So why do we want to work with time series, which is going to be a fair bit of this webinar? Time series define behavior. They give us reference modes, and they also allow comparison with what happened, whether it's a qualitative or a quantitative comparison. You can look for patterns in relationships. Now, correlation does not mean causality. We need to be careful there. But you can look, kind of see how things relate to one another. It's important to remember, though, that data availability should never drive conceptualization. It does not bound a problem. You conceptualize it, it's based on what's happening in the real system, not the data that are available to measure that. Data also allow injection of outside influences driving variables. So a couple definitions, these are terms I will be using. Parametric data, I just mean time and other constants, like how long it takes to perceive the delivery delay, to use a really old example. Initialization of values, what's the initial population? Time series data are numeric values that are different at different times. So we'll be looking at a bunch of those. Obviously, that's the bread and butter of the models we do with Stella. And then there's what I call structural data, which includes array definitions, and we'll talk about importing and exporting those, but it includes a lot of things we don't import or export: decision-making relationships, causality, physics, units of measure, all the things that go into building a really fine Stella model. So I'm going to start with a basic import process. I'll open up the model and kind of show you how to import the data. And this model I'm starting with right here is a very simple model, simple population model, but it's also one that everything is set to 0 at. So we have a carrying capacity of 0, an average lifetime of 0, a birth rate of 0, a population of 0. If I run this model, nothing happens because everything is set to 0. What I want to do is I want to get some values for things like the population, the carrying capacity, and whatnot, and I want to get those from a different data source. So what I can do is if I go to Model, Import Dataset, up in the upper right-hand corner, there's a little button that says Make Template, and if I click on Make Template, it will offer to make a template called template.csv in the data folder. we'll see this a bit more, that there's a kind of a folder structure that we typically use, and typically there is a data folder that is used to store data, both for input and output. Get a little bit more sophisticated than that in a couple of the examples here, but I will just say, okay, I want to do that, and I want to include graphicals, which is checked by default. And I'm going to just organize things horizontally because I find that easier. Click OK. It'll ask me if I overwrite it because there already was a template there. I'll click OK. And now if I go over to folder structure and look at my basic import and my data folder, I can open up that template. And this will by default open up in Excel. It's a CSV file. And we can see that what it is it has the values in the model for this population. I have another copy of the population model that's arrayed inside of a module called arrayed, just so that you can see how that works. But I'm really going to focus on the scalar part. And you can see it's got the values that I put in the model, which is to say everything is 0. Now I have another file here, which is called basic import.csv, which is really just that template file, but then taken and I put some numbers in. I've given an average lifetime. I've put in a initial population. So if it's a stock and you're importing it, it's going to be an initial population. It'll be the initial value for the stock. And I can then go back to Stella and I can choose that basic import.csv file. And it's going to, by default, control variables, leaving equations unchanged. And I can check it by clicking on the import button. And if we get this nice thing that says import executed without issue, it means it was able to import it. And if I go back to the model now, you can see that there are markers on the different variables in the model that were imported. We imported everything but births and deaths in this case. We went up to the arrayed model, we'd see exactly the same thing. And if I run this model, we now have behavior over time as each of the values that came in from the imported sheet are used in the model. So we have it for the scalar model, and I've also graphed it for the arrayed model, which has different values for different things. So that's how you can bring in a set of constants, and in this case, a graphical, and see and use those in doing a simulation. So that's controlling values, and run it, we see the results, but we can also load data as a run. Now, in loading data as a run, what we're doing is we're looking for an external data source. And did that really fast. So just so you know, there's a little disk drive icon here, data called the data manager. If I click on that, it opens up this dialog. And one of the buttons on this dialog is to load external data as a run. If I click on that, it asks me where to find it. And I'm going to go to recorded values. And I click OK. And what happens is recorded values is then loaded in as a run. It's put at the beginning. It's marked save. And it's imported from an external source. It's marked. But now if we were to go and look at population, we could see the first run I did, nothing happened. The second run I did, which is not number 3 because of the way it reordered things, we can see population growing. And then from the data, this recorded values, we can see what population is doing. And the same would be true if we went into this for each of the different array elements here, we would see a different behavior of population. So this is an easy way to get in data from an external source. If I restore all devices here, that external source is marked saved, so it persists. And then when I run it again, I will just get the comparison of what the model is doing now relative to that external source. So that is a way of loading data as a run. And the other thing you can do is you can bring in time varying values. So I just brought in what I called the parametric values before, but I also in my little folder here have something called birth rate input. And birth rate input is it's over months. I have a birth rate and I have a birth rate for the different arrayed elements, and it's varying month by month. And if back in Stella, I mark import, and I add it as an import. So I'll continue to use the basic import, but I'll add this as an import. And I will browse for it, and it'll be birth rate input. And I will say load time varying values. And when I do that, now when I run the model, the birth rate, instead of being a constant, is showing up as a time varying value based on the input in that file. And if we go back to the input in that file, we will see that the time points 0, 1, 3, 4, 5, 18, 18.25 are not uniformly spread out. They're just values of which points where you have data. And it interpolates between them, although there are options to either hold it constant and or use the raw data when you're working with data that's imported that way. So that's basic import process. It's fairly straightforward. It gives you a lot of flexibility in terms of bringing in data to a model. And then I want to look at the basic export process, which in a sense is the reverse of the import process. I'm going to have a model where we have some results, and then I can target either CSV or text files. CSV text files are XLSX. CSV is much faster when you're working with large amounts of data. It's actually what I prefer to in most of the production work that I do. But the CSV file has a disadvantage that if you open it in Excel, which is how I'm going to be opening it to look at things, you can't export it. You'd have to close it and then export and then reopen it. So I will actually open this one up in Excel. And one of the things that I do in working with XLSX files is set an option, and that's under the preferences, to leave Excel files open when exporting from or importing from or exporting to them. And what that means is that when I go to, that's still in basic import, I need to switch to basic export. So let me just close this, not save it, and switch to basic export. Okay, so this is the same model, but it's got values filled in for birth rate and death rate and whatnot, and I can run this model and see the results. And now I'm going to go to model, export data, and I'm going to browse and choose an Excel file. And I'm going to choose horizontal again because I have a preference for that, but leave everything else the same. And when I click on the export button, it says it exported without error. And now if I go to my various Excel files, one of them is called basic export. And it has all of the values for all of the variables at all of the times, which is the default for the export. We can actually control what gets exported from this dialog. For example, instead of exporting everything, I could have exported everything that's in a table. Click on export, it's happy, go back to Excel, and Excel is now laid out the same way that the table is in the underlying model. Or I could export everything that's tagged as output. Now, the things that are tagged as output in this model are shown in blue. And I click on export for that. And it gets upset, which it sometimes does working with Excel. And it will just export the things that are tagged in blue. So what I'm going to need to do probably is, I will export it to a different location and open that up. I'll export it to a CSV file. I'm going to skip over that part. Just so you can export a table. Tagged variables, let me just talk a little bit about tagged variables. A tagged variable is something that's marked with the as output. To solve this problem, I need to close Excel and close Stella and start over again. But I don't want to interrupt the webinar to do that. It takes a little bit of time. It's marked as an output. So I've tagged that. This one, for example, is not marked as an output. And then in the styles for the model, I've said anything that's marked an output, fill it in with a light blue color. So you can see that. And you can see I've also done the same thing with arrayed variables. So this is actually a very convenient way to choose a set of things that are marked for output. And the other thing that you'll notice in the export dialog is that you can also choose, for example, the one set of values which will export only constants, not values over time. And if you export only constants, you can use those and re-import them as constants, for example, in another model. And you could have a separate tag variable, I do this quite often, that would export some things as constants and other things as values over time. Arrays can also be imported, array definitions. So I'm going to open up a little model that has some array definitions in it. It's called array def. And it's there's really nothing to this model, just the array definitions I really want to focus on here. So it's got a thing called bakery location, which is a label E1, or location, which is E1 and E2. So bakery location is what's called a subrange of the location. And if I run this model, it doesn't do anything because, like my population model, it was just filled with zeros. But what I can do is I can ask to import some definitions for arrays from this. And if I go back to my file explorer and go to my array definitions data, I've done this one in Excel as well. I have an array definitions which says that location is going to be here, there, and everywhere. And bakery location is going to be here and everywhere. And you can notice what I did was I just repeated here and I left blank one of the elements for bakery location. So this importing data this way, importing array elements this way is actually a pretty convenient way to create subranges, things that are only partially included in a complete range. And then in this model, I can go model, import data. I can select that, and then I select the array sheet for that. That's the one we were just looking at. And I'm going to say set array dimensions. I'll get a little warning saying that when new values are imported, all undo redo, and that's a little bit scary. So what I'm going to do is I'm going to accept that, but I'm going to mark this on demand, which means it will only be imported when I ask to import it. I'm going to do that right now by clicking on this button. It's happy. If I go back to my model now, you can see that we have here and everywhere for battery location, and here, there, and everywhere for location. So I've imported the array definitions from that model, from that Excel file. And I can also import data now, which is also in the Excel file, which is going to be parametric data. So I'm going to browse, choose the same file again. This time it's giving me values because it's already used the arrays sheet. So you pick which sheet, but I've only got one choice in this case. And this is just going to be controlling values. And I'm happy. And if I run this model now, I have a little error here, which I will quickly fix by doing this. Okay. And then run the model, and I can see that I have different values for the different array elements, the way it was set up in Excel. So that's a way to import array definitions and kind of use that to go forward working with array definitions. Order is obviously important here. You want to import the array definitions before you import the values, parametric values, or the parametric values will not make sense because the array definitions won't match. And I did the on demand, which means that if I were to change the parametric values, I'd have to explicitly import the array again. A trick for importing the on demand things is the import all command, which is the same as Shift plus Control plus M. And it's a good way to test to see whether or not there's anything wrong with that. So if I do this now with keyboard shortcut, it says all imports executed without issue. If I were to go to the Excel file and put something in values, for example, not in model, and say that was 5, and now try to import that, I would get a message saying we cannot find the variable not in model. ignored. So it lets you know if there's something wrong, a mismatch between the data you're trying to import and the what's in your model. The next thing I want to talk about is opening data as a model. And this is a relatively new feature that we added to Stella, but it allows you to take something that is a data source, so it could be a CSV file or it could be an Excel file. Typically, it's a CSV or a text file. By the way, we use CSV files here. Text files are tab delimited, and they also open and export just fine in Stella. I do tend to use CSVs because I guess that's what I'm used to using. And when you open data as a model, variables are automatically created. It includes the modules and arrays, and it may need some adjustments. Let me go and do that. I'm going to just close out here so I don't have anything open. And then I'm going to go open, and I'm going to navigate to my data as model folder, and I see there's no model there. But if I ask for all file types, I will see that there is a CSV file there. So I'm going to double click on that CSV file, and I get a whole bunch of warning messages saying variable was missing from the model diagram, because this was not actually a model. So all the variables were missing from the model diagram, but you can see that they're now in it. I have an arrayed version that has everything in it as well. And if I run this model, every one of these has the behavior that exists in the data set for it. Now, these things are not connected together. There's no structure. Population is not marked as a stock, but we have everything now that we can kind of look at and explore the data. And the other thing that can be true is that you could go in and, for example, copy all of these and paste them into another model that might have other things that you want to work with. So this is a convenient way to quickly get data from a CSV or a text format or Excel, really, from any format into a model and start working with it. Now, one of the things that's true is if you go to the array editor, that it's got this thing called dimension 1, which is others, ours, and theirs. Doesn't know what to call this because the import data set is just values. It doesn't have any array definitions, but we can change this to store, for example. I can't remember what I called it. No, sorry, region, as I called it in the other model, and it doesn't change the way the various elements work. So that's how you can actually open up a data set as a model and work with that. And if you want to merge multiple data sets, you'd have to open them up as separate files and then copy and paste the things that were opened. But which means it's just a quick way to set up an import. And the final, actually, it's not the final, almost second final to last thing I want to talk about. It's a little bit more complicated. It's data consolidation. How do you go from data that might be in slightly different forms at slightly different levels of aggregation to something that you can use in the models that you want to be working with? And so I'm going to kind of walk through this by walking the directory structure, so to speak. I'll start at the, let me start at the root. Let me close this. I'll discard it, and I'm going to open up data consolidation, and it looks kind of normal. I've got a thing called main model. And main model, I'd like to import some data, and I've set up this so that the imports are already defined. It's trying to import data from time data. But if I try to import it, it tells me there's an error because time data is actually empty at the moment. I haven't managed to fill it out. In order to fill it out, what I need to do is I need to go into the data consolidation folder, into the data folder. Under the data folder, there's something called consolidation. And under the consolidation folder are two different types, two different subfolders, aggregation and transaction to time. And then a consolidation model, which takes the output of aggregation and which takes the output of these and then consolidates to something that can be consumed by the main model. So let me first do aggregation. It's got an input and an output. The output is what this model will create. The input is product detail. So here I've got something that's just fairly simple. We've got like 5 years of data, finishing at M1, M2, and M3. And if I go back to Stella and open up my aggregation model, Then I can run that model, and I get values for this, as you can see, and I get values for production. And I've marked finishing in blue as an export. And so when I ran this model, if I look at the export data, it's marked with exporting data to production.csv based on that tag output. And it happens every time I run the model. So I don't actually have to open this dialog again. It automatically exported. If I wanted to check to make sure the export was good, simply click there, I check, and I run with that. So that's the aggregation model. And there is often also a consolidation. What have I called it? It's a model called transaction to time, in which the input is something that's not really time series. I've used the fiscal year as an array element, and I want to convert this into revenue and cash flow over time. And the way I can do that is I can, go back to Excel. Open, let me close this model. Don't have too many models open, and I'm going to open the transaction to time model. And this transaction to time model takes those inputs and then kind of explodes them out with funny equations that allow us to convert an array element into something that happens over time, and then sums them up for that, and then marks them as outputs. And if I run that, I get values now output for the two different things that I'm using. And now I can go back to, I'm actually not saving these models, but in many data processing models, it doesn't matter, because what you're really doing is you want the inputs and outputs to be fixed up. And I've already done that by running the model. And so I will open up my consolidation model. And my consolidation model takes revenue and just re-exports it. It takes cash flow and creates a thing called cash flow data and exports that. And my production model takes finishing and makes a thing called finishing data and exports that. And now if I go back to, so if I run this model, I can check to make sure everything exported just happily. And now if I go back to my main model, I can run it. And if I look at production, I get the production values that were coming out of, I should get the production values. These are not showing up. So I can get, it's not showing revenue values. I will fix these files up. I'm going to make all the files available during the webinar. Available as a zip file. I will make sure that this is working. I'm not sure what I did wrong there. Made a little mistake, sorry. But that's basically the process by which you take model that's in different forms, aggregate it up, and make it usable by another model. Starting with the most unprocessed data, kind of the inputs, and then we take submodels. This is two submodels feeding a third submodel, feeding the main model. That's atypical. Typically, I only have one data consolidation model, but I wanted to demonstrate the two different kinds of consolidation that are quite typical. And it was easier to do those in two models. That is data consolidation. And then the final category of working with data I want to talk about is data formatting. And this is importing from and exporting to Excel. And really, this is just a matter of making things available to people in a way they might be used to. And Excel is a pretty common form for things. Let me close out these extra models. And I will go to data formatting, open up the data formatting model. And when I open this model, it computes some things. If I go in and there should be a data formatting Excel file way down here. And what I've got is inputs and outputs. And so I can say, okay, I want to make receipts be 200 and 300. I'll leave shipments alone. And then I can see what I was getting in terms of a stock. This is what I was getting before. If I go back to Stella and I run this model, we can see that my flow in is now 200 and 300. And if I go back to Excel, I can see that I have receipts of 200 and 300, which gives me a huge stock further down the road as these things accumulate. Now this spreadsheet, and as I say, I will make this available, has some hidden rows in it, which are actually the things that are working with Stella. So this is two Stella time varying values. So these are flows in and out over time. We're importing these as time varying values. If I unhide again, here's a constant, which is inventory, the initial value of inventory. If I unhide again, this is stuff coming from Stella. So we're actually exporting to this sheet. We're exporting in a standard format, and we're exporting, I think in this model, I had some tagged variables being exported. But this allows us, with those sheets hidden, to just work with a very simple Excel interface for putting data into and bringing data out of a model. It's just a comment on exporting from the interface. I'm not actually going to demonstrate this, but you can import and export from the interface in a very, very similar way. The type of imports are detected automatically on the interface. So you simply say import from a file, and it will look at the file and determine whether it seems to be a set of parameters, time varying data, or array labels. Array labels are a second part. We didn't do that. I actually changed the array elements when I imported arrays. Array labels can be added to array elements. You can't change an array definition because that changes both the size, can change the size of the array, but you can change the labels that are displayed in graphs and tables from different arrays, which is a convenient way of customizing something that's been published, for example. And then the other thing, obviously, you can do is export from a interface. And export is simpler. Basically, you're getting values over time. You can use different sources for those values. You can use a tag, which is the most convenient one, as we did in the export example I worked with. But you can also use tables, which is essentially becomes a list of variables. You can actually just provide a list of variables. There's also an option in interfaces to export changed parameters. And the purpose of that is to allow rerunning. So you export those and then import that same file back, and you end up being able to repeat any run that you had done with the existing files. So in summary, Stella provides a pretty rich tool set for working with data. Use obviously what you need. The examples I've shown here are quite simple, but they actually have the structure you need to do fairly complete work. So I use import and export all the time in my work. I use a lot of the different techniques I've shown you here, and they can yield some very, very nice results. It's what really gets done with the data that's important in the end. So parameterizations are used for initialization. Typically that's done by controlling values. And exogenous drivers are typically brought in through controlling values over time to be able to make changes over time. Calibration is most typically done by importing data as a run, which I did with the very first data import model, where I pulled in the results so we can compare them to the current runs. And then exploration, obviously, is opening data as a model and kind of working with that. So these are all the kinds of things you can do with data using Stella, and hope I obviously went very, very fast. There's a lot of material to cover here. As I say, the models will be available to you after the webinar. I will fix up the little problems that we were having displaying data in my consolidation version example, and make that available. So I'd like to open it up for questions and comments. Please type your questions in the chat. Hopefully I can answer it. I've also got here a few places you can go to for support. If you want to email me directly, I'm just bob@icsystems.com.
Thank you, Bob. I did have a question right off before I go to the questions from the audience. In your consolidation model, is it possible that you were loading time varying values? Because it was showing the points, but nothing in between.
Oh, you may have better eyesight than I do. So yes, it's possible I was loading time varying values and I had marked them raw by mistake, in which case it would only show the points and not connect the lines between them, which may be what was going on.
Okay, great. So that's something for everybody to know. That's sometimes very valuable to intentionally do that. We have a very detailed question. If you'll bear with me, I'll read the entire thing for you. I am constructing a model that will have starting stocks and parameter constants that vary over 64 different counties. I would like to be able to bring in all 64 county starting stocks and parameters into my Stella model. I would then like to run the model in a way that when I created a front-end interface in Stella Designer, the user could choose a specific county and see that county's model results. Would I set this up with arrays, run the Stella model, and then have Stella Designer interface filter the specific county array element to show that county's result?
So that is the way I would typically do it. Now, with 64 counties, depending on the size of the model, you may end up with a relatively big model. But if it runs quickly, the drop-down I showed, I didn't really show you how to create it, but you can create a drop-down that's an array selector. And then they would just go in and select the county they wanted to work with and use that as the input. So as long as the model is small enough that it runs relatively quickly with all 64 counties, that's actually the preferable way to go because it lets people quickly switch between the different counties to see the results for different counties.
And that's a great lead into the next question. You used in the array example, you used that selector, didn't you? Could you just explain that a little bit to everyone?
Sure. That's a good idea. So I go back to here and I will open up the array definition model again. And here you can see I have E1 and E2. Actually, I did this in the basic import model. It might be the better one to do. So in the basic import model, inside of arrayed, I put this array selector down. So if I run this, it's got no results. I didn't do the import yet, but this thing, these are a little bit hard to select because they're made, go into edit mode and highlight over it, it will select it. And then look at the properties and you can see that it's called a dropdown. Let me just show you how to create one. That's probably a better explanation. You go to the drop down, you go to selector, drop a selector. It can be either for a placeholder, which we're not using in this particular model, or for dimension. If it's for a dimension, you just choose which dimension. And then once you've got that, you can move through that. And you'll see I've got two different ones that are for the same thing. And when I move one, the other one moves at the same time. So this is a handy way to kind of move through different elements of arrays. And this is available both on the interface as well and works exactly the same way.
Thank you. The next question is, do you have any specific strategies or recommendations for data calibration?
Absolutely. There's a fair bit on calibration. There's a webinar on calibration that we did a couple of years ago. One of the tricks to that, and I don't really have time to show it here, is to create a placeholder for all of your calibration variables and then put on a graph the calibration variables versus the model run, and then just go through that selector, which is we just used here for arrays, but for placeholders, and you can look at the different variables you have calibration data for one at a time, which is a good way to kind of get started on that. Once you've done that, then it's to go through the calibration process, and the webinar is probably a good resource for that, as is the documentation.
Thank you. There do not seem to be any other questions right now. Does anyone have a question they'd like to ask about this webinar? We seem to have run out of questions, Bob.
Okay, well, appreciate very much your attendance. As I say, we'll make the models available and happy to answer questions if they come up afterwards. Just send us an email. Thank you very much.